Imagine standing on the edge of the ocean, looking across an endless stretch of water. Now imagine someone tells you they are planning to build a dam, not across a river, not across a valley, but across the sea itself. Your first reaction would probably be the same as almost everyone else's. Why? After all, that is not what dams are normally built for. For thousands of years, people have used dams to control rivers and store fresh water. A river follows a clear path toward the sea. Build a barrier across that flow, and water collects behind it. Simple. The ocean is different. Its level rises and falls with the tides, while currents constantly move enormous volumes of water. Trying to block part of it sounds less like engineering and more like trying to stop the wind. So why would anyone even consider doing it? As strange as it sounds, engineers in India have been studying that exact idea for decades. Their proposal is called Kalpasar, and on paper, it sounds almost unbelievable. Build a dam stretching roughly 60 kilometers across the Gulf of Kambat in western India. Not to stop a river, but to separate part of the sea from the open ocean. If completed, the enclosed area could eventually become one of the world's largest man-made freshwater reservoirs. At first, that makes almost no sense. How can you create freshwater by trapping seawater? Wouldn't everything inside simply stay salty? That question is the key to the entire project. Because the engineers behind Kalpasar are not trying to desalinate the ocean, they are trying to change what flows into it. Every monsoon, several major rivers carry huge volumes of freshwater into the Gulf of Kambat, where it mixes with the Arabian Sea. Engineers saw an opportunity. What if that freshwater could be captured before it reached the open ocean? Instead of damming each river separately, one barrier could retain much of their combined flow. Over time, continued river inflows and controlled releases could gradually reduce the salinity inside the enclosed basin. So why has it not been built? Because the Gulf of Kambat is one of India's most difficult marine environments, and the ocean will not make the job easy. The idea is surprisingly elegant. The location is where everything becomes unbelievably complicated. That's the thinking behind Kalpasar. Instead of building dams across every river, one barrier at the mouth of the Gulf could capture much of their combined flow. Fresh water would continue flowing into the enclosed basin, while controlled water management would gradually reduce its salinity over time. The goal isn't to turn seawater into fresh water. It's to keep fresh water from mixing with the sea in the first place. If that works, the benefits could be enormous. A vast freshwater reservoir could supply cities, industries, and farms while reducing pressure on groundwater. The dam could also provide a direct transport link across the Gulf of Kambat, significantly shortening travel across Gujarat. One structure could improve water security, transportation, and regional connectivity, which is exactly why engineers have studied the idea for decades. But understanding the concept is one thing, building it is another. But here's the real challenge. Unlike calm reservoirs, the Gulf of Kambat has some of India's largest tidal ranges. Twice a day, massive volumes of seawater create powerful currents that constantly move sand and sediment. Building a 60-kilometer dam in that environment isn't like building across a river. It's building while the ocean is constantly trying to undo your work. That's where the real engineering battle begins. Designing the dam is only part of the challenge. Keeping it stable is something else entirely. Unlike a river, the Gulf of Kambat never stands still. Its tides reverse direction every few hours, creating powerful currents that constantly reshape the seabed. Engineers wouldn't be building on solid, predictable ground. They would be building in an environment that is always shifting beneath them. Most people picture the seafloor as solid ground. In the Gulf of Kambat, it is anything but. Sediment is constantly moving. Channels shift, sandbanks appear and disappear. That means the foundation of the dam must remain stable even as the seabed around it continues to change. That's why engineers rely on years of geological surveys, tidal measurements, and sediment modeling before a project like this can even begin. Then comes the weather. India's west coast is exposed to tropical cyclones that bring strong winds, rough seas, and storm surges. A construction site stretching nearly 60 kilometers across open water would have to withstand rapidly changing conditions while keeping workers and equipment safe. Building the dam isn't only about efficiency. It's about designing for some of nature's most demanding forces. And those aren't the only challenges. The structure must also be designed for seismic activity, powerful tides, shifting sediment, strong currents, and tropical cyclones, all at the same time. Each of those problems can be solved individually. Combining them into a single, reliable design is what makes Kalpasar so difficult. That's one of the main reasons the project has remained on the drawing board for decades. And yet, one country has already shown that building across the sea is possible. If anyone understands how to hold back the sea, it's the Dutch. But even they know this project is unlike anything they've ever built. At first, the idea sounds impossible. A dam across the sea, facing tides, storms, and shifting seabeds. But engineers have done something similar before. In 1932, the Netherlands completed the Afsluitdijk, a 32-kilometer sea barrier separating the Zuiderzee from the North Sea. Over time, rivers flowing into the enclosed basin gradually replaced the saltwater with freshwater, creating the IJsselmeer, now the largest freshwater lake in the Netherlands. An idea that once seemed impossible had become reality. For Kalpasar's engineers, the Dutch project proves one important point. Separating part of the sea from the open ocean can work, but that's where the similarities begin to end. The Gulf of Kambat presents a far more demanding environment. Its tides are larger, its currents transport far more sediment. The proposed dam is almost twice as long. The region also faces tropical cyclones and seismic activity. The Afsluitdijk provides valuable experience. It does not provide a ready-made solution. Kalpasar still presents engineering problems on a scale that has never been attempted before. The Gulf of Kambat is even more demanding than the North Sea. Its tides are stronger, currents faster, sediment more aggressive, and the seabed constantly changing. It also faces tropical cyclones, seismic activity, and a proposed dam nearly 60 kilometers long, almost twice the length of the Afsluitdijk. The Dutch project offers valuable lessons, but not a blueprint. Kalpasar presents engineering challenges no one has solved before. That's why Kalpasar has remained under study for so many years. The question is no longer whether engineers can separate part of the sea from the ocean. It's whether they can do it safely, reliably, and for generations to come. Because building the barrier is only part of the challenge. Keeping the water clean, protecting ecosystems, and managing the reservoir over decades may prove just as difficult. Imagine the dam is finally complete. The Gulf of Kambat has been separated from the Arabian Sea. It might feel as though the hardest part is over. In reality, a different challenge is only beginning. A barrier can store water. It cannot guarantee that the water will remain clean. What happens next depends on the rivers flowing into it. Every river carries more than fresh water. It also carries sediment, nutrients, and in some places, pollution. Once that water enters a largely enclosed reservoir, much of that material remains there instead of being dispersed by the tides. That means the quality of the reservoir will depend heavily on the quality of the rivers feeding it. A dam can preserve fresh water. It cannot purify it. Then comes another question. What happens to the life already in the Gulf? The Gulf of Kambat supports entire ecosystems adapted to salty, tidal waters. A freshwater reservoir would gradually transform that environment. Some species might adapt. Many wouldn't. That's why engineers must study fish migration, coastal ecosystems, and fisheries before construction begins. Because changing the water means changing an entire ecosystem. Then comes another challenge: time. Projects of this scale are measured in decades, not years. During that time, technology improves, costs change, and new environmental studies continue to refine the design. Every survey answers one question, while raising another. That's one reason Kalpasar has remained under study for so long. Which brings us back to our original question. Why build a dam across the sea? At first, the idea sounds absurd, until you realize the goal was never to stop the ocean. It was to preserve fresh water before it mixed with the sea. Whether Kalpasar is ever built remains uncertain. Only future engineering, environmental, and economic decisions will determine that. But the project has already challenged one assumption that most of us rarely question. Does every river have to end at the sea? This is not just the story of a dam. It's the story of an engineering idea that challenges something most of us take for granted. For centuries, rivers have been seen as ending their journey when they reach the sea. Kalpasar asks a different question. What if part of that journey could continue? But simply asking the question has already pushed engineers to rethink what might be possible.